Hey you guys, welcome to the bonus video here, getting ready for the bonus for your first quiz on polynomials, and this is just showing a connection between the regular basic version of the quadratic formula, of a quadratic function. So if we have f of x equals, our basic formula is ax squared plus bx plus c. That's the general format for any quadratic. What we're going to do here is we're going to walk through the completing the square process, but we're going to do it and leave the variables in the process as letters instead of as numbers. Okay, so we're going to keep the variables in place. We're going to do all the same steps that we would normally do for completing the square. It's just that we're keeping the letters there. Okay, so for step 1 here, let me zoom in a little bit. If we are finding the zeros of this function, the first step is of course to set f of x equal to 0. So that's what you see me doing here. Then step 2 is to, once I have it set equal to 0, remember, we would very much like for the coefficient on our x squared term to be 1. And so if that's going to happen, we need to divide all the way through this equation by a. So that's what you see in step 2 here. X squared divided by a is just a 1x squared. Bx divided by a is b over a times x. And then my constant divided by a is just the fraction c over a. So now that I have cleared out my x squared, now I'm going to move my constant over to the other side, and I'm going to complete the perfect square trinomial here. So we need to identify, in order to complete the perfect square trinomial, we need to identify what number is going to complete that square. So remember, we're going to take the b over 2, and in this case the b I have in quotes, you guys, because it's really just the middle term's coefficient, or the linear term's coefficient, and in this case that's b over a. So notice I have b over a, but all still divided by 2, and then all of that squared. So the first thing I do is just to say, if I'm dividing b by a and then I'm dividing by 2, it's really like b divided by twice a. And if you guys wanted to do keep, change, flip off to the side, that's what this would look like here. So we would have b over a times, instead of divide by 2 over 1, it would be times 1 over 2, and that gives you your b over 2a. So that's half of b, and then I need to actually square that, remember, to complete the square. So we're going to take our b over 2a all squared. Remember, squaring a fraction like this means squaring the numerator and squaring the denominator. So we actually get b squared over 4a squared here. So this is the number that completes the square, so this is the number that's going to be added to both sides of my equation. And that's what you see in step 5 here. Then in step 6, we're looking at simplifying the left-hand side by getting a common denominator between these two fractions. With a denominator of 4a squared and a, we're going to adjust this fraction, negative c over a, by multiplying its numerator and denominator by 4a and 4a, and then we get 4a squared. And then notice we're going to put our 4a and c just in alphabetical order as we combine those numerators into one fraction in step 7. And we have b squared minus 4ac. That should look pretty familiar to you, all over 4a squared. So that's the progression of the left-hand side there between steps 6 and 7. Now let's talk about the progression of the right-hand side of the equation. We're going to change from this trinomial form back here in step 5 to, in step 6, this is our binomial squared format. And remember, that is just simply always going to be x, match that linear term's sign. So if this is plus, so is this. And then remember, half of the linear term's coefficient. And we already determined back here that that was b over 2a. So that's what's going there. Okay, I think we're all set now to get back to the whole process, and we're in step 8. So step 8 says now that we have it in that form of binomial squared form, we're going to take the square root of both sides. When we take the square root of both sides, don't forget we get a plus or a minus of the square root of that whole entire fraction on the left side that was there before. And the square root of the right-hand side, because it is also squared to begin with, is just the expression we had inside the parentheses. Then in step 9, we are going to be simplifying the square root, and remember we do that by pulling it apart, so we have the square root of the numerator by itself and the square root of the denominator. Well, the square root of the denominator is just 2a, because the square root of 4 and the square root of a squared separately can be taken. And then we're going to move this constant term from the right-hand side, the plus b over 2a, to the left-hand side because we want to solve for x. That's the process of completing the square, is to make it easy to solve for x. And then, finally, in step 10, after we add these two fractions, which already have a common denominator, what do you have now, you guys? You have the actual quadratic formula. And yes, I'm going to sing you the song, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know that's annoying, and I know it's kind of childish because it's Pop Goes the Weasel, but that's how I learned to do the quadratic formula, and I have never unlearned it, so maybe it'll get stuck in your head in a good way. Alright, you guys, that takes us to the end of this proof video. Hopefully you're going to shoot for the stars there and try to duplicate this proof on the bonus for your polynomials quiz. I'll see you guys next time.